Welcome to Dr. Balaga's God Knowledge Doc podcast, your quick dive into the latest medical breakthroughs to keep you ahead of the curve. Let's get started. This video is on a fascinating paper published in Nature online, hot off the press, 5th March 2025, titled A Subcortical Switchboard for Perseverative, Exploratory, and Disengaged States. How does the brain decide, persevere, explore, or disengage? Understanding the neural mechanisms behind decision making. Research based on the median Raphe nucleus, previously referred to as the superior central nucleus of the Raphae, or nucleus Raphae centralis superior. The big question: how does the brain decide whether to keep going, try something new, or give up? These strategies impact mental health, survival, and adaptability. This study focuses on the median Raphe nucleus as a central decision-making hub. The neural switchboard, the median Raphe nucleus, the brain's decision-making hub, regulates behavioral flexibility. There are three key neuron types: GABAergic neurons, which promote perseverance; Glutamatergic neurons, which drive exploration; and Serotonergic neurons, which maintain engagement. How was this studied? The investigators used optogenetics, controlling neurons with light, fiber photometry, measuring real-time neural activity, circuit training, mapping brain connections, behavioral tests, T-maze for decision-making, self-stimulation for evaluating emotional balance, and the nose poke task in measuring task engagement. And this was studied in rodents. Key findings: what did they discover? Suppressing GABAergic neurons, the mice perseverate, sticking with familiar choices. Activating glutamatergic neurons, the mice explore more, switching frequently. Suppressing serotonergic neurons, the mice disengage, stopping interactions. How the median Raphe nucleus integrates information. It works through the lateral hypothalamus, sends reward signals to the median Raphe nucleus, promoting perseverance. The lateral habenula sends aversive signals, leading to disengagement. The median Raphe nucleus balances these inputs to guide behavior. Clinical relevance, implications for mental health. OCD is linked to excessive perseverance and compulsions. Depression is associated with disengagement and lack of motivation. Potential therapies: deep brain stimulation, serotonin GABA modulation, and behavioral interactions. Future research: what's next? Mapping median Raphe nucleus' downstream circuits to see how it affects decision making. Exploring median Raphe nucleus interactions with prefrontal cortex for higher cognition. Investigating how these mechanisms apply to humans. Conclusion, final takeaways: the median Raphe nucleus is a switchboard that balances perseverance, exploration, and disengagement. Understanding the median Raphe nucleus circuits could revolutionize mental health therapies. Future research will explore therapeutic applications. After decades of painstaking research linking prefrontal cortex dysfunction, basal ganglia loops, and limbic circuits to psychiatric disorders, we now learn that a tiny midbrain structure is the real mastermind behind OCD, depression, and decision-making paralysis. If only we had known, we would have skipped the prefrontal dopamine models, the serotonergic projections, and the cortical-subcortical interactions, and gone straight to zapping this neuropsychiatric Rosetta Stone with optogenetics. Anyway, as you all know, neuroscience is not a single switch solution.